Okay, let's get right into it. So we're doing application now on analytical geometry. In the previous video, I showed you how to use the distance formula, which is which is given as MB. So AB is the square root of x2 minus x1 squared plus x2 y1 squared. So here we're really dealing with typical exam questions, something they can ask you on such a topic. So if you don't know basics of this, please check the other video. It will help you very much. And then it's number one. Number two, the midpoint. The midpoint we said is given as x2 plus x1 over 2 y1 or y2. It doesn't really matter here. Just make sure that you choose your coordinates properly. And then notice with this, it doesn't have an equal sign in between, so it gives you the coordinate of the midpoint. And number three, the gradient is given as this y2 minus y1. So in this video, it might be quite lengthy because I want to go step by step on each and every one of these questions they can ask you. So let's start. The first question they can ask you on distance. So application on application of the distance formula. Application of the distance formula, they can ask you what? They can ask you to prove shapes. Very important. So you need to know the properties of each and every shape. This is grade 8 and grade 9 work. So once you're in grade 10, 11, 12, we assume that you know the properties of all your 2D shapes and you know how to prove those shapes. So let me write this down quickly for you. Triangles, we have how many? How many shapes we have of triangles? 4, I think. Yeah. We've got an isosceles. I'm just going to name them randomly. Isosceles triangle. How do we prove an isosceles triangle? Two sides are equal. So if they say prove that is an isosceles triangle, at least when you're using the distance formula, you must have two sides that are exactly the same. 2, not 3. 2 of them must be the same. Number 2, you've got a scalene triangle. No sides are equal. I hope that's good English. So all the sides are different. So if you're proving that it's a scalene triangle, they can give you the points and say what type of a triangle is this. So you're going to find the distance of all the 3 shapes. Triangle has 3 shapes, and then once you find that the distances are different, then you say it's a scalene triangle because the distances are different. Another one is about equilateral triangle. How do you know it's an equilateral triangle? There must be how many sides equal? So all the 3 sides must be equal. So if we can find the distance of each and then find that all the sides are the same, then it's an equilateral triangle. I hope you get it. And the last one, put it right there, it's a right angle triangle. So if they say prove it's a right angle triangle, you might have to use the theorem of Pythagoras, of which I will not I will not do in this video. So you might have to say, okay, right angle is like that, A, B, C. So if we, oh my God, okay. If you're supposed to prove it's a right angle triangle, you need to prove that AC, the longest side, the one that is opposite the right angle, is equals to the sum of the other 2 sides, all squared. So you might have to do this. You might have to find all the triangles and prove that if I add up these 2 and square them, I actually get this one. I hope you get it. It's very important. It's very, very, very crucial that you know these things because of they will ask you along these lines. And then, okay, things are falling apart. Okay, here we are now. We're dealing with quadrilaterals. I don't know how many quadrilaterals. How many shapes do we have? I don't know. Please find it and comment there for us. We've got a no. I'm busy. Okay, cool. Sorry about that. Okay, a quadrilateral triangle is what? Number one is a parallelogram. So this is a quick, it's gonna be long. It's a quick revision on all your 2D shapes. So what do we know? I'm not gonna write the properties. Let me just write quickly the shape. So this is equal to that is equal to that. So opposite sides are the same. So if they say prove that this is a parallelogram using the distance formula, you're gonna find the distance of this, and then if they are the same, you say therefore it's an equilateral, it's a parallelogram, and then this angle must be the same as that angle must be the same as that angle, but we're using distance now. We're not really on what do you call it, on angles. Diagonal lines bisect each other, so you can also prove using that this side and this side are the same, that exactly the same, or this one and this one are the same. So along those lines they're also parallel. So if you're using distance formula, we can the gradient formula, we can also use that. So we've got your rectangles. Do I really have to write all of them? No, I don't have to. Thank you. Your rectangle there forms a 90 angles. The sides are parallel. A square, all the sides are equal. A rhombus, all the sides are equal. Opposite angles are parallel, like that, like that, like that. So you need to know a kite, adjacent sides are equal. Adjacent side, yeah. So you need to know all of those things. You need to know all of those things for you to be able to apply the distance formula accurately. So let's do one question, because I feel like I've been talking a lot without proving my story. So we're gonna do 2 questions under each, and then that will be about it for this topic. So they say in the diagram, can I write it there? In the diagram, can you see properly? The vertices, the points of A, B, C are given as point A is 2 and 3, point B is 5 and 7, point C is -2 and 6. All right. The question says 2 questions, wonderful questions. It says prove, okay, show that this triangle ABC, okay, triangle ABC is an isosceles triangle. So how do you even show that? How do you even know? What is it, an isosceles triangle? You have to know by now 2 sides are the same. So we're going to find the distance of all of them. 2 sides are equal. Okay, number 2 question, it says calculate the perimeter. So also you need to know area and perimeter. Calculate. So I hope you see it, that analytical geometry is a fun section because it combines parts and parts of other topics. You can all see that. So you need to be able to calculate the perimeter. Okay, let's move along. So you can sketch this on a Cartesian plane. We don't have time for that. I mean, we want to apply. So I'm going to find the distance of AB in this case. Ooh, it's going to be a long question. So I'm going to find it after the length of BC, 2, 1, x squared, y2 minus y1 squared. So you start by choosing. Obviously, you go back there, choose this one, y1, x1, x2, y2. Then you go ahead and substitute. Okay, so it's 5 minus 2 squared plus 7 minus 3 squared. Here I get how much? 5 minus 2 is 3. 3 squared is 9. So I'm skipping some steps. 7 minus 3 is 4. 4 squared is 16. You get 25. Then AB is 5 units. AB. Can you all see? Sorry about that. Okay, let's do this one now. So I'm doing BC now. So this one can be x1, y1, x2, y2. I hope you saw the coordinates. So let's substitute now. In this case, it's minus 2 minus 5 squared plus y2 is what? 6 minus 7 squared. And then we get the answer. This minus this is minus 7. Minus 7 squared. All right, this is about to get interesting. Okay, let me write it down. It's minus 7 squared plus minus 1. Why are you using a calculator? Because so this is 7 squared. 7 squared is 49. What am I even doing? I did 14. So 7 squared is 49 plus this is going to give you 1. 1 squared is 1. So this question becomes 50. And then 50, we can break it down as like that. Then find the square root of each. The square root of 25 is what? 5. And the square root of 2 is not there. So that will be your answer. Okay. You get it. So we've got one as 5 squared, 5 units. The other one is 5 root 2 units. Let's leave it like that. And we have to do the last one, which is AC. A and C. So you go back again. So this one is already x1, y1. This one is x2, y2. So I'm going to keep it in this order. Okay. Write the formula x2. So what I'm doing, I'm getting used to writing the formula so that I know it off by head or off by heart. Minus 2 minus 2. Can you see it? This one is a negative. That one is a positive, and we have a negative there. Plus this one is 6 minus 3 squared. So this minus this is going to be 4. It's going to be 3. Can you all see it? And then 16 plus 9. There you go. 16 plus 9 is 25. Therefore, 5 units. All right. So we have proven that AB is the same as AC. And BC is on its own is different there. So we have proven. Therefore, triangle ABC is an isosceles. Okay, isosceles triangle because that's how you write, because two sides are equal, which is what and what, which is AB. AB is the same as AC, and we've got one side that is on its own. There you go. I hope you learned something very important. So this is what they're going to ask you around, especially when we're dealing with the distance. This is when you apply the distance formula. Now let's do another question they can ask you on this wonderful topic. They can actually give you the distance formula. The distance, I mean. So let's read this question. Calculate the possible values of K. Can you all see the possible values of K if the distance between A and B is 5 units? And then you're given the coordinates of A as 2 and 5, and the coordinates of B as what? -1 and K. Wonderful. So in this case now, you are given the distance between A and B. You're given that A and B is how much? It's 5 units. And you are actually given the coordinates. So you can see, calculate the possible values. So we might get more than one value, because we're looking for the coordinate. What would be here to make the distance 5 units? That's what they are asking basically. So all right, So it can be two values because of we are squaring, not a train smash. So I said, you still remember the other formula that I gave you? That's when it becomes useful now. This one, it's not different. Squaring, I get rid of the square root by squaring both sides, so AB has squared. Then I choose, go ahead and choose which one is x1, y1, x2, y2. I think I should just, did I make one long video or cut them into bits and bits? Alright, that doesn't matter. Let's go on. So AB, are we looking for AB in this case? No, we are given AB, it's 5 units. So I'm gonna have 5 squared equals 2. X2 is how much? Now this is where it becomes interesting. So you're gonna substitute the way you normally substitute. Squared plus y2 is how much? K minus 5. Okay. Then we try to solve the one that are solvable. 5 squared is 25. Minus 1 minus 2 becomes minus 3. Minus 3 squared becomes 9. I hope I didn't miss anyone there. And this one means the same bracket twice. So I'm just going to go ahead and expand. Expansion. Then I can write this in the flip side. Okay, let me take everything to one side. So take the 25 this side, becomes 0. 9 minus 25. Okay. Plus, we still have those two brackets there. 9 minus 25 is how much? Minus 16. I need a calculator there. Okay, then we are going to multiply in. Do you still remember term 1's work where we are simplifying two binomials? So we're gonna multiply this and that. K times k, it's k squared. K times minus 5 becomes minus 5k. This and this becomes minus 5k, and negative becomes a positive. 5 times 5 becomes 25. What are we doing? We're looking for the possible value of k, right? So you shouldn't be lost at what is happening here. You should catch along. So the left hand side is equals to the right hand side. So I'm gonna take this and bring it there, take this one, bring it there. I'm not doing anything. Okay, to make it easier, you can try to solve the ones that are solvable before we do that. 25 and 16 are like terms. This and this are like terms. So I'm gonna be left with k squared minus 5 minus that one becomes how much? Negative 10k. 16 minus 25 becomes a positive 9. Can you see? Then let me take this and put it that side so that we have it in a proper way. So this is actually called the standard form. The standard form, you start with the one with the squared, the one with the coefficient of x or k, and the constant becomes the last one. So here we're gonna factorize using a trinomial. Can you see? Factorize a trinomial. If you don't know how to do a trinomial, trinomial. If you don't know how to use a trinomial, you wouldn't be able to answer such a question. This question needs you to be familiar with your algebra, simplification and factorization at the same time. So what do? We do our favorite method. Favorite method says take the product of the factors of this, the product of the first term, which is k squared. K squared is made by k times k. Then write out all, so we take the first and the last, all the factors of 9. So 9, I can get 9 by 9 times 1 or 3 times 3. But in this case, I'm going to have to choose the product that will give me 10. If I add them up together, because I look at this sign, it tells me that we're adding. When I add them up together, I must get 10. So which one will I choose? 9 and 1. If I add 9 and 1, these two factors, they're going to give me 10. These two, if I add them up together, they will give me a 6. Remember, we use the product of the first term and the last term to get the middle term. So in this case, I'm going to choose 9 and 1. And then you can actually do cross multiplication and see it, but we're not gonna do that. I'm just gonna go ahead and say these are my brackets. K and 9 and K and 1 equals to 0. Then we go to the signs. If here it's a plus, then the signs inside the bracket are the same, and we take the sign of the middle term, so it will be both minus and a minus. Then we apply the zero factor rule. Zero factor law says equate each bracket to 0. So K minus 9 equals to 0, or K minus 1 equals to 0. Therefore, the value of K in this case will be 9, or the value of K will be a 1. So there's your answer right there. Perfect. Massive. It's a question they would ask you, so please be on the lookout on such questions. They might ask you to do that. Another question they can ask you is to show that 2 points are equidistant, meaning they are the same distance apart from each other. So as long as you can find the distance formula, you can apply that. So I don't know, should I continue or should I pause the video? Okay, let me pause the video and do another one exactly the same time right now on midpoint and gradient.